Pandas is great for analyzing data in Python, but do you know that it can also be used for data visualizations? Yes, it's a very handy and easy method to plot some simple graph to understand the data you are working with. Today I am working on an exercise to review the plots which can be plotted using Pandas built-in data visualization tools. Please watch along if you find it interesting or feel free to work alongside if you want to practice these codes too. So let's get started. So first up, we will start by importing our libraries. So here we imported NumPy, Pandas, matplotlib.pyplot, cbound, and we use a one-line code %matplotlib inline, which is used for showing the visualizations in the Jupyter notebook. Next up, we have to import the CSV file called df3. So to upload the file, we type pd.read. As you begin typing, press tab and it will give you options for all of the Excel files or CSV files which you want to upload. You can use tab to complete the code and just put in your file name. Remember, the file has to be within the same folder in which your Jupyter notebook is located. Otherwise, you will have to give the full file path. Next, we have to use info method to check the data frame attributes. So here we see that df3 is a data frame which has 500 entries. So the range index is going from 0 to 499, and it has four columns with column name A, B, C, and D, all of which has 500 non-null values. Therefore, there are no null values in any of the columns, and all of these data are float data. So let's check the data. Next, we will check the head and tail of the data. So here we have used the head and tail method, and as we can see in the head, we have the first five rows ranging from 0 to 4, and we have our float data in all of the columns. Similarly, the last five columns, or rather the last five rows, have the float data as well. So in the middle, the data is going to be somewhat similar to what we have here as well. Next, we have to recreate this scatter plot of B versus A. So B is on the y-axis and A is on the x-axis. This A and B are the columns A and B from the data frame. Note the color and size of the points. Also note the figure size. See if you can figure out how to stretch it in a similar fashion. So that's simple. We will use the fixed size argument for that. So let's start coding for this. So here we will use the data frame df3 dot plot dot scatter. So if we check the signature of that, we have an x argument and y argument. Those are for the x and y axis. Then we have an s argument, which is for the size of the scatter plots, and c, which is for the color of the scatter plots. So first let's start by inputting x and y argument, and let's see what that brings. So this is the graph which x and y plots. So let's use the color red for C, and we will also try to increase the size of the plots. It looks pretty similar, but we will see what that changes. Alright, we use the red argument for C, red color for C argument, and we give S is equal to 25. If we can try different sizes here. This is clearly too big from the given graph. We can try 10 as well. Now it looks too small, so we can go back to 25. That kind of matches with the given plot. Also, if you can see here, these have black outlines, and here we don't have black outlines, so we could do that using the edge color argument. Now we have the black outlines, but the outlines look too thick compared to this figure. So we can change that, the width of the line as well, using line width argument. So we made the error of putting this as a string. Let's try with LW is equal to 1. LW is shorthand for line width. Still, it looks too big. I think it looks okay. The other thing we have to adjust is the figure size. I think the size looks okay. It's stretched out. Uh, there are some other adjustments we will make. See how the x axis here goes from 0 to 1 in my plot, but in the given plot it goes from minus 0.2 to 1.2, and similarly the y axis goes from minus 0.2 to 1.2. So we could make those changes as well using the x lim and y lim arguments. Just pass in those coordinates which you want using a tuple. Yes, so it looks similar now. The one other thing is the levels and the numbers on the axis looks too big. So let's try to change that as well using x level size and y level size argument if those are available for the scatter plot. Okay, so this argument is not available for the scatter plot. It would normally be available for some of the plots, which we will see later. So here it looks similar. We will leave it at that. So let's move on to the next graph now. So here we have to create a histogram of the A column. So let's start plotting that. For that, we will take the A column and then use dot plot dot hist method. And if you check the signature here, we have a by argument, we have a bins argument, and other histogram keywords can go in there as well. Let's just plot this first and see what it shows. So one thing first is the size of the figure is too big compared to what's given below. We can set a global size on the Jupyter notebook we are working so that all the figures which are produced are of that particular size. If we don't do that, we will have to manually input the size of each of the figures. But if you want all of the figures to be of the same size, we could set a global uh, size for everything. So we will do that here. What we will do is pass in a matplotlib argument. So this argument is plt.rc_params, and inside that pass figure.fix size, and we will change it to 4.5 3.5 for now. Then run this graph or run this plot once again and see the change in the size. So now, so now it looks somewhat similar, but here there are some differences. This is a continuous plot, whereas the bars are clearly visible because of the black outlines here. We will adjust that. The number of bins looks to be similar, so we won't change that now. Let's just change the color and put the black outline, and let's see what that produces. Yes, the graph looks similar. We could change the line width as well. And the other thing to look here is that the x-axis on this given figure goes from 0 to 1. Here it is slightly different, so we can adjust that. Yes, now both these figures look similar. We will move on to the next graph, which is also a histogram. So these plots are okay, but they don't look very polished. Use style sheets to set the style to ggplot and redo the histogram from above and figure out how to add more bins to it. So that is simple, but first we have to use a style sheet. Style sheets are automatic styling sheets given in matplotlib. If you go to the matplotlib website, you will see a few style sheets options given. For example, one we have to use here is ggplot, but apart from this also there's one called pmh, and there are other options given as well. Those would have pre-decided styles for the color and the background and everything else related to aesthetics. You could use those. I will show you how to use it here. Just run this, and now if we plot the above histogram graph, it should come out in this format. So let's copy the code from above. So this code had a color argument. We will remove that. And let's see what it gives. So there are two things. First, on the aesthetics front, we have given an edge color argument here for black, but here we have white. So we will change this. Also for the number of bins, this has more bins than this figure. So let's change the bins to 25 and see if that works. So I think the two figures here match perfectly. Yes, the only thing is this is very bright and this is more muted. So we can change that using the alpha argument to make the graph more transparent. Yes, it looks similar now. Next, we will move on to create a box plot comparing A and B columns. So what we did here was we selected the A and B columns within the data frame. So this part of code produced just a new data frame with just A and B columns. And then we plotted the box plot, which looks similar to the figure given here. Next, we have to plot a KDE plot just for the D column. So for that, we selected the D column and used the code .plot.kde, and the plot looks similar. We can change or we can adjust the line width and also the alpha argument to make it more transparent. Yeah, so it looks similar now. So next we have to increase the line width and make the line style dash. Here we can adjust the x-axis to just go from negative zero point 0.5 to positive 1.5 using the xlim argument. Also, there are a few different line styles if you want to see. So these are the styles we can use. This this produces a solid line. You can put in the string solid as well, This will produce a dash line, dash dot, and this is used for the dotted lines. If you put in the argument none, then it will not produce any line. Let's try for the dotted line. So this one looks more similar, but we don't need the dotted. The question asks us to use a dash line, so we will go back to that. Now here this x and y levels are too big, so I will try to make that smaller using a context uh, argument. If you check here, we have four options going from paper, notebook, doc, and poster. As you go from left to right, these options, the x level and y level text and numbers will become bigger and bigger. So we will use the paper context here and run this code again and see how this numbers look slightly smaller now compared to earlier. You can check with this graph as well. Next we have to plot this area graph, and that is just for rows up to 30. Here the question asks us to use .ix method, but that has been deprecated, so we will use the ilog method, which is used to select the range index. Remember this uh, second number is exclusive, so to select the rows up to 30 we will have to use 31, and then once we have selected our rows we will plot the area graph. So our graph looks similar. The only thing is we will use the alpha argument to increase the transparency of the plot. And I adjusted the x-axis to go from 0 to 30 as given in the figure. Rest everything looks similar. So next up we have to try to move this legend, which is overlapping some of the part of the graph here, outside the graph. So this will produce the same graph, and now to move the legend out we can use a matplotlib argument. And so there are two options we can use here. One is the location argument and the other is bbox to anchor. So let's try with bbox to anchor, or let's try with legend first and then I will show you the bbox to anchor. For the location, you can give numbers ranging from 0 to 10 that will place the legend at different positions within the graph. So to move this legend box outside the figure, we can also give in the coordinates using a tuple format. So what this one by one means is it moves the figure 100% of the way to the right and 100% of the way to the to the top of the figure. So we'll change this slightly 1.01, so it is just outside the figure, and then we will go halfway up 0.5. So see, this works. The other way we could do this is also using the bbox to anchor argument. So this bbox to anchor has anchored this box at this location. We can move this up by changing this argument. Yes, so it looks to be in the same position now. So it looks similar now. Uh, so that's all for this video. Thanks for watching.